Okay, so an interval and an instant. We're talking about time here. So sometimes we want to look at velocities over time, a time frame, an interval of time. You've been doing this already. Your favorite formula for this, velocity is equal to change in distance over change in time. So obviously that's looking at velocity over an interval of time because we have a change in time there. Another one for looking at average velocity is this formula here. V average is equal to V1 plus V2 divided by 2. Now that one's only good for special cases at certain times. We can use it, however, for this graph here. So there's a couple of time intervals listed there from 0 to 4 seconds and from 2 to 6 seconds. So let's find the average velocity for those. So if we want to see what the velocity was at time equal to 4 seconds, we can just do that, set up a crosshairs, and you can see that the second velocity for that formula will be 2 meters per second. Divide that by 2, and you get the average velocity. So that time interval was 1 meter per second. All right. Now does that kind of make sense? Because if you look, what is an average? It's kind of like the midway point, right? If we take the average of all your test scores, we get kind of the midway point for the classroom. Well, this velocity is increasing. It's a nice straight line, so is it increasing at a constant rate or not constant? Constant. It's a linear relationship. So it kind of makes sense then that halfway along the line here would also be the average. Okay? So you can do the second one there, and you'll get from 2 seconds to 6 seconds. So at 2 seconds, the velocity is, sorry, doing that wrong. At 2 seconds, the velocity is equal to 1. So 1 meter per second plus, at 6 seconds there, it's equal to 3. 3, divide that by 2, and you're going to get that the average velocity is 2 meters per second. So what is the velocity when time is equal to exactly 3 seconds? Yeah, about 1.5, right? Now, is it ever, at any other time period, equal to 1.5 meters per second? Well, if we go just a little bit below 3 seconds, then the velocity is a little bit less, right? If we go just a little bit above, it's a little bit above 1.5. So at that one particular instant of time is when we have that velocity. Now, in other examples, you may have a whole bunch of instants in time in which you have the same velocity, but this was just to kind of illustrate that for the average velocity, we're looking at it over a period of time. There has to be a change in distance, a change in velocity. If we're looking at just at one particular moment in time, it has a singular velocity. So in this case, that would be 1.5 meters per second. So now I just want to talk about all the different types of velocity. I just want to really set it out clearly because too often students get confused. They'll confuse average velocity with initial velocity or final velocity, or even change in velocity. So I just want to kind of go over what the different labels of velocities are. They're not always used this explicitly. Sometimes it's just referred to in its general sense of velocity. And it's up to you to interpret what the question or what the problem is. All right, so for the first one there, V, car, or duck, or ball, or anything really. That is the velocity of the object. Usually we only use those when the velocity is constant for a time interval that we're looking at. So for all the perpendicular vector addition questions we've been saying, you know, the duck flies or the boat goes across the river. I mean, we all know in real life those things vary their velocities, but we're kind of taking it as their constant or average velocity over that time interval. So that's where that kind of a label would come in, you know, the velocity of the car or whatever. Average velocity, I have seen some textbooks refer to it this way, AVE, not many, but some. And it's just like it sounds, it's the average velocity. We've been using that formula, delta D over delta T. That's what's supposed to be there. Don't know where it went. But that's over an interval of time. Okay, that's what these first two are. It's an interval of time, so you have to have a change in time and a change in distance. The next one here, VI or VF or VT equal to whatever. So you might say VT equal to 3 seconds or something. So VI or VF or V time equal to whatever. These are a specific instant of time. So not average. So you're not using delta D over delta T. It's one of those weird formulas that we've kind of looked at on the board there, but haven't really explored all that much yet. Initial and final are the most common. They're the ones that you'll be using the most. But it could be at any instant of time that you want to look at. And then there's this one. This one comes up every once in a while. Delta V. Now what does delta mean? Change. Change in. So this is change in velocity. Again, a common mistake I've seen is someone calculates the average. So they'll use that formula there, delta D over delta T, and they must see all those deltas and think that, well, this must be delta as well. And then they'll throw it into an equation that has delta V in it. They're not the same thing. This is change in velocity, so this would be one velocity minus another one. So initial velocity subtract final velocity, or the other way around. That's not the same as average. So please be aware of that and be very careful with that one. So even though we often think about things happening in an instant of time, such as a ball hitting a wall and rebounding back, they do actually take some time interval and some distance. So here's a video of a baseball. I'm not sure how it's going to show up on our video, but you can check it out on the website. So you can see the baseball is approaching a wall, it compresses, and it rebounds. So it stopped for one instant of time. It had a velocity of 0 meters per second, but from here to where it stopped, it actually had to slow down. And it took some time and some space to do that.